boxes for type, voltage rating, number of poles, rated current IN, RCD operating current and its operating time, measured at fault current.
A lot of this information can actually be picked up from the device. On this main switch here, we can see that the current rating is 100 amp, it's rated at 230 volts, it's a BSCN 60947-3 and it's a 2-pole device.
The boxes requiring RCD operating current and operating time would only require values where the main switch incorporates an RCD, otherwise not applicable should be written here.
Yes, and remember it's the details of the main switch, not the RCD sitting beside it.
Let's now consider the schedule of items inspected, found only on the electrical installation certificate and not the EICR. Now we cover this in some detail in another video and also in books. So in this video we'll only consider some of the additional considerations which may have to be made. The first of these being cross-referencing the schedule to data filled in elsewhere on the form you're filling in.
A good example of this are some of the boxes under the subheading Automatic Disconnection and Supply. In particular, presence of main protected bonding conductors. If there is an NA, for example, because a building has no water or gas, then you would not expect to see a tick in the relevant boxes for bonding of extraneous conductive parts. We see this kind of thing more often on electrical installation condition reports.
The same issues are true for any box on the schedule which is confirming the presence, and in some cases operating current, of an RCD. If there's anywhere else in the form which records details about RCDs, this should be cross-referenced to the schedule and should agree with it. A common misinterpretation can occur when electricians confuse requirements for RCDs to provide additional protection against electric shock and those, say, which may be installed to provide fire protection. For example, a 300 mA RCD which may be provided for fire protection would not result a tick in the box presence of residual current devices under the subheading of additional protection. This instead would fall for consideration under the box choice and setting of protective devices.
Another thing to point out is that no box on the schedule should be left blank. For the electrical installation certificate, there should be a tick or a not applicable in every box.
It's important to remember that the inspection schedule only relates to the work that you've carried out. For example, if a new cooker circuit is installed, then more than likely you wouldn't be checking for supplementary bonding, segregation of safety circuits, cell, etc. And therefore these boxes will have NA. The circuit details and test results take up a full page on both the EIC and EICR, whereas the minor work certificate only deals with information for a single circuit and so has an abridged version. So the first issue I'd like to tackle, Tony, is how this should be filled in to best represent the installation you're working on. Now, for example, it's common to have a split load consumer unit with 2 batches of RCD protected circuits. So what's the best way to show this on paper?
Well, Dave, there's no hard and fast rule on this, but here's an example of what I would do. As you can see, each RCD takes up 2 rows, which gives me plenty of room just to write down the circuit it protects. These circuits are then written underneath with the circuit number. I've also used a ruler to bold up the line before the second RCD and its associated circuits. Depending on whether the form has pre-printed circuit numbers, it may be necessary to either overwrite these or write the actual numbers under the circuit designation column.
Most of the columns requiring information about each circuit are fairly self-explanatory, but we will quickly run through each. Next we have type of wiring, and in brackets it's got C code.
For ease of information, the codes are listed on the side of the page. For example, code A means the type of wiring is thermoplastic insulated or sheath cables. There is also an option of O, meaning other, and a box for you to describe the type of wiring used.
The column for reference method refers to Appendix 4 of the regs, and to methods of installation for which current carrying capacity has been determined by test or calculation. Table 4A2 of the regs gives examples and a description of installation methods and reference method to be used to determine the current carrying capacity of the cable.
For example, if I look at table 4D5, which is the current carrying capacity for twin and earth cables, you'll see that there's 6 reference methods. Reference methods 100 to 103 are to do with thermal insulation, depending on the thickness of the thermal insulation. And reference method C is if the cable is fixed direct. Now it's these reference methods that will go in the box on the circuit details.
Next, we have number of points served. Now this is referring to the termination of the fixed wiring intended for the connection of current using equipment. For a lighting circuit, this is only the luminaires served, not switches or number of individual lamps used.
And for socket outlets, if you have 10 double sockets, you have 20 outlets, but it's still only 10 points.
Next, we have the cross-sectional area of live and CPC conductors. If you're using standard twin and CPC cables, you shouldn't have many issues here, as there are tables published for the complete range of conductors from 1mm squared up to 16mm squared.
The next column is titled Maximum Disconnection Time Permitted by BS 7671. This is the value determined by the designer from the relevant table in Chapter 4.1 of the regs, and is information that we need to cross-reference later with the ZS test results. You will see from table 4.1.1 that for circuits not exceeding 32 amps on a TN system, the maximum disconnection time is 0.4 of a second. For a TT system, the maximum disconnection time is 0.2 of a second. For circuits exceeding 32 amps or distribution circuits, the disconnection time can be extended to 5 seconds and 1 second respectively.
The next 4 columns deal with the details of the overcurrent protective device for each circuit. For circuit breakers, this information can be taken from the device, just as we did for the main switch.
However, where not available, you may have to consult the manufacturer or refer to other published guidance, such as the on-site guide. The capacity is referring to the breaking capacity, so the current which the device can interrupt safely. And for a BSEN circuit breaker is displayed in a rectangular box. As the heading of the column is KA, it may be necessary to convert from amps to kiloamps. The following column is for the operating current of any RCD protecting the circuit. Don't forget this includes RCBOs. For our circuit detail sheet we saw earlier, it will only be necessary to fill in the RCD details in the rows set aside for the 2 RCDs. And then you can put a ditto in the rows underneath for each circuit.
Next, we have maximum ZS permitted by 7671, and this information is taken from the relevant table in Chapter 4.1. For example, our cooker circuit is protected by a 40 amp circuit breaker, and Table 4.1.3 tells us that maximum ZS is 1.15 ohms. Well, that's the circuit details covered. We now have the test results section. The first 3 columns are for little r readings for ring final circuits only, and not applicable can be recorded for all other circuits. Next we have 2 columns for big R readings for all circuits, but only 1 column need be completed for each circuit. For initial verification, it is good practice to do the R1 plus R2 option. The R2 test is usually undertaken on periodic inspections as a convenient method of determining that a CPC has been provided at every accessory and outlet.
One quick word about the big R1 plus R2 box. I've seen this filled in for ring circuits with the values of little r1 plus r2 added together. This is wrong. The correct values are achieved during step 4 of the ring final circuit continuity test, when a line conductor from one leg of the ring is cross-connected to the CPC on the other leg and vice versa, and resistance readings taken between line and CPC at each socket outlet, the highest value going in the big R1 plus R2 box.
The next 4 columns are for the results of insulation resistance tests. The first column, line-to-line resistance, is for a three-phase circuit where tests are undertaken between each phase of the supply. The lowest value of resistance measured should be written in the box, or not applicable if the installation is single-phase. Then we have line and neutral. Again, for three-phase, you would have to test between each line conductor and neutral and record the lowest value. And repeat again for the next column, line and earth. Finally, there is neutral and earth. Tony, although there are boxes for each and every circuit, the wiring regs do allow for insulation resistance to be taken on the board as a whole. So if you've done it that way, is there a preferred way to fill in the form?
Well, you can do it in a number of ways. There's nothing wrong with writing a value in every box. Although, if you have, I think you should write on the form how you did the test. For example, ball tested as a whole. Alternatively, you could fill out the top boxes and then add a bracket like this with additional commentary.
What about if you've done the alternative test with line and neutral cross-connected, so you reduce the chance of damaging certain equipment?
For that, I would cross out existing words and write in the top row L and N to E, meaning line and neutral connected together, tested to the earthing arrangements. I will then draw a bracket and write the resistance readings before filling in the rest of the boxes with dittos.
Next, we have a column for polarity. Now this box is only a tick box. There's no value required. As we've seen in our other videos, there are a number of ways of confirming polarity, and the tick confirms that this has been undertaken for every connection of the circuit. So there is a possibility that on a condition report you might find limb written here. For example, if it wasn't possible to gain access to a socket outlet concealed by furniture. Remember, any limbs recorded should also be detailed in either the agreed or operational limitations box on the front of the condition report, which we'll look at later.
Next, we have maximum measured earth fault loop impedance. And this is another box which can cause problems, especially when compared to the box maximum ZS permitted by BS 7671. Usually, what happens is the electrician takes a reading, sees that it's lower than the maximum allowed ZS from the regs and thinks everything is fine. Unfortunately, the maximum ZS needs to be adjusted by the 80% rule of thumb method before comparison. This allows for the difference between conductor temperature during normal operation and the colder conductor temperature during testing.
For example, if the maximum ZS for a circuit in the regs was 2.3 ohms and the measured ZS was 1.9 ohms, on the face of it everything seems fine. But reduce the maximum allowed ZS to 80% of its value and you get 1.84 ohms. Which tells us we have a circuit which may not achieve the required disconnection time of 0.4 of a second in the event of a fault.
Don't forget that all the NICEIC certificate and form pads have the 80% values on the inside front cover. These values are used for comparison when testing, but not to be recorded on the certificate or report forms. Next, we have two columns for RCD operating times. The first is the operating time at the rated residual operating current of the RCD, which is required for all RCDs and RCBOs. The second column is for the disconnection time when tested at 5 times the rated residual operating current. This is only a requirement for RCDs installed to provide additional protection against electric shock. So RCDs with a rated operating current not exceeding 30 milliamps. There is a third column here for checking the operation of the RCD by pressing the manual test button. If the RCD operates, a tick shall be inserted here. Before we leave this section, Dave, there's just a couple of other boxes that can be incorrectly filled in on this sheet. The first is designation of consumer unit. This should be how it's described by the manufacturer. For example, 12-way split load. It's not for the manufacturer's name. I even once, many years ago, saw someone write the name Gary in here. It wasn't right, but it had me laughing for days.
I suppose you're going to tell me next you've seen on the wall written in location of consumer unit.
Don't have to answer that, do I?
Again, for this box, the location should be a recognisable description. For example, kitchen, garage or understairs. Finally, at the bottom of this sheet are boxes for the serial numbers of any test instruments used. This is vital, as it allows for the instrument calibration history to be checked with the manufacturer if required. If you're using a multifunction test instrument, it's considered good practice to put NA in the other boxes.
Actually, Dave, we should just quickly mention the first line on the schedules page, which is only to be completed where the consumer unit is remote from the origin of the installation. So we will put the details of the circuit supplying the consumer unit in here.
We're now going to focus on some of the particular issues with the minor works certificate. As this is only used for an addition or alteration to an existing circuit, it's just a single sheet of paper. So, for example, it doesn't have separate circuit schedule and test results. However, much of the information we've examined so far in this video will be required in Part 2 and Part 3 of the certificate.
There are two boxes in particular which require important consideration. The first is details of departures, if any, from BS 7671. Sometimes it is thought that this is always referring to departures in the existing electrical installation. This may be the case, for example, where a circuit protection device is manufactured to BS 3871, which is a standard no longer recognised by the current regs. But its use is also for situations such as where possible non-British or European standard equipment is being installed as part of the work.
Yes, this is one of those cases where allowance is made by the regs as long as it can be proved that the equipment installed is no less safe than similar equipment which does meet the required standard.
It's more common for comments on the existing electrical installation to be placed in the big box under details on the modified circuit.
And how far would you expect the electrician to go with regards considering the existing installation?
It's about making a judgment. If you see enough problems to give you doubts about proceeding with the work, it may be appropriate to recommend to the client that an electrical installation condition report be carried out. If they don't want to do it, and you've seen problems which you consider dangerous, you may like to issue them with a domestic electrical danger notification. The client may not want to sign it or accept it, but as far as the electrician is concerned, he has taken appropriate action.
Before leaving the minor work certificate, is there anything in the inspection and testing part that needs clarification?
Well, as you can see, it's an abridged version of the inspection and test schedules we saw earlier, and everything on it we have examined. I will point out though that although the minor work certificate is for an addition to a circuit, we are still required to verify by visual inspection that there's an earthing conductor connected to the consumer unit from the means of earthing, and also that where protective bonding is required for extraneous conductive parts, it exists.
Finally, under this section, we have agreed limitations, if any, on the inspection and testing. Now, we'll examine this more when we look at the electrical installation condition report form. But the important word here is agreed. Any limitation must be agreed with the client, ideally before the work has even started.
Before we leave the minor work certificate, as previously stated, remember, it's one minor work certificate for each circuit worked on.
With the introduction of Amendment Number 1 of the 17th edition, a major change was that the form used for periodic inspection and testing altered considerably, not only changing the name to Electrical Installation Condition Report, but also the way observations are coded, and it includes a comprehensive list of items that require inspection.
The number of changes, especially the detail on the inspection schedules, are considerable, and I recommend watching our video on electrical installation condition reports, which goes through the schedule in detail.
For this video, we'll focus on some of the key areas, and first, let's look at the purpose of the report.
Now, I've seen all sorts of stuff written in here. A particular favourite was to check the condition of the electrical installation. Now, if they'd added the words because the required next inspection date on the electrical installation certificate was due, this would have been fine.
You could also have checking condition of electrical installation after a fire or flood, or due to possible house purchase, mortgage or remortgage, as long as the reason is clearly understood. The next boxes we're going to look at are incredibly important, and these are extent of the electrical installation covered by the report, agreed limitations and operational limitations.
The first box is extent of the electrical installation covered by this report. In some cases, this might be second floor only, or downstairs lighting only, or it might be whole installation with the exception of the smoke alarm circuits.
The agreed limitations box ties in with this. It is vital to agree with the client before you start what you can and cannot do. This is all about providing evidence in the future if required.
It's important to state that this box requires that you must also state whom it was agreed with and the reasons.
So what kind of things might we find in the agreed limitations box?
Well, a common one is likely to be that no insulation resistance test was made between line and neutral. The reason would be because all lamps and current using equipment would have to be removed, and in most cases this is totally impracticable.
The next box is operational limitations. So what's the differences between that and an agreed limitation?
That's a very good question, Dave. Agreed limitations have been agreed with the client before you start. However, operational limitations are issues that have arisen whilst carrying out the report, which have prevented either inspection or testing of a particular item. Again, the reason must also be recorded.
An example might be that access may be restricted to lighting, perhaps because of height or because a loft is inaccessible. Another change with the EICR is the codes used to classify observations.
There are 3 observation codes used to determine the degree of urgency for immediate action. These are C1, C2 and C3.
C1 means danger present and immediate remedial action is required.
C2 means potentially dangerous and urgent remedial action is required.
Code C3 means improvement recommended.
When it comes to making the overall assessment of the condition of the installation, any C1 or C2 conditions that have been identified must result in an unsatisfactory outcome.
Sometimes it will be necessary to indicate that further investigation will be required to decide whether an observation does pose an immediate or potential danger. If this is the case, the overall assessment of the condition of the installation must also be reported as unsatisfactory, as detailed in the Best Practice Guide on Electrical Installation Condition Reports produced by the Electrical Safety Council.
The condition of the electrical installation and the number of codes and their severity will have an effect on the decided date of the next inspection.
The date of the next inspection is at the discretion of the inspector. For example, in our EICR video, the property has lower insulation resistance values than would be expected for its age. Therefore, Tony set the next inspection to 6 years.
The final box for us to discuss on the EICR is the summary of the condition of the installation. Now, I've seen poor or needs a rewire here, but these are not accurate statements. In real terms, you should provide a clear summary of the condition of the installation, having considered, for example, the adequacy of the earthing and bonding, the suitability of the switchgear and control gear, the types of wiring system and its condition, the serviceability of equipment, including accessories, the presence of adequate identification and notices, the extent of any wear and tear, damage or other deterioration, changes in the use of the building which have led to or might lead to deficiencies in the installation.
Because there's only a finite space for this information, it is advisable to send a covering letter to the client with the completed EICR. This is a chance to expand and explain upon the summary in non-technical terms, and also provide a recommended list of remedial actions. We're going to finish today by looking at information particular to the electrical installation certificate.
One box we didn't discuss is maximum demand, which is under particulars of the installation at the origin. Normally, this figure would be the maximum demand taking into account diversity calculated by the installation designer. However, for work which is adding additional circuits and loading, it may be necessary to determine the existing maximum demand before commencing with the work, so that it can be ascertained that the wiring and the equipment installed, especially at the origin, is suitable for the additional load.
One acceptable way to determine a realistic maximum demand on an existing installation is to use a clamp meter where possible at the line meter tail, and then switch on as much current using equipment as possible. So what next, Tone?
The final box to discuss is the number of smoke alarms. We discussed these earlier, and although you can write in the quantity, you must remember that the additional certificate entitled Certificate of Design, Installation and Commissioning of a Fire Detection and Alarm System of grades B, C, D, E or F in a dwelling must be issued as well.
And anything else?
I'd finally like to remind everyone that if the electrical installation certificate is for an initial verification on a whole electrical installation, then there must be no crosses or limitations on the certificate. If any defect was found, for example, damage caused during construction, then this must be rectified before the certificate can be issued.
In this video, we've examined some of the key features and applications of the Minor Domestic Electrical Installation Work Certificate, the Electrical Installation Condition Report form, and the Domestic Electrical Installation Certificate.
For further guidance, check out other publications available from the NICEIC and Electrical Safety Council, and also the superb videos featuring Dave and me.
See you soon.